Fine. Again, I welcome you all to our YouTube channel, Math Universe with Dr. Naseer Ahmed. And yeah, the students have joined. Rashiro, okay, good evening. Vinod Kumar, good evening. Harini, good evening. Alia, good evening. Yes, I hope now it's audible. Kindly confirm. Is it audible now? Am I audible? Ah, yes, good. Okay, fine. So, as last week, see, we have been finished with so far two live sessions for second PUC. First one, we went for continuity and differentiability, followed by second was on application, sorry, application of derivatives, indefinite integral and definite integral, nothing but integrals. Differential equation, differential equation is pending, which we are going to take today, along with relations and functions and inverse trigonometric functions. And within this week, again, we are going to have one more session on matrices, determinants. If possible, one more chapter will include. Okay, and by next week, Monday or Tuesday, I'll be going with vector 3D and probability. Okay, so now with this, let us start with the chapter differential equation. Differential equations. Now let us try to understand what is differential equation. Any equation involving derivatives with respect to one or more than one independent variable and surely free from constant, arbitrary constant. What's the meaning of that? See, if I just give an equation y equal to f of x, come on, I would like you to interact. It should not be only one-way traffic. Come on, y equal to f of x. What do you think? Which is it a differential equation? Is it a differential equation? Kindly comment. Yes, no. Is it a differential equation? Y equal to f of x. Yes. Okay. Harit says not a differential equation. What about others? Okay. It is not a differential equation because this is free from derivative. There is no derivative. So any equation involving derivative with respect to one or more than one independent variable and having a dependent variable. For example, dy by dx, derivative of y with respect to x is equal to x square plus 7. This is a differential equation, and as you can see, derivative is involved and it is with respect to only one variable. Let us suppose we have got more than one variable. So here y is a function of x alone. Okay, so this will be actually called the ordinary differential equation. This we call ordinary differential equation. Any equation having only one independent variable, and y you can see depending on only one independent variable. Okay, this we call ordinary differential equation. Whereas let us suppose that I have got a function u. U is a function of both x and y. Nothing but u is depending on both x and y. And now we have got more than one independent variable. So let us suppose I am going to have one differential equation of this form. This we pronounce as partial derivative of u with respect to x, partial derivative of u with respect to y. This is partial differential equation. Partial differential equation. This we are not going to discuss this year. In your higher studies undergraduate level, you are going to have a discussion. Now our entire chapter will be depending on ordinary differential equation. Nothing but derivative will be with respect to one independent variable, and the dependent variable will be depending on only one independent variable. So henceforth, in place of saying ordinary differential equation, we are going to only say differential equation. Okay. Before I proceed, any doubts? Am I The explanation, is it fine? Can we go ahead? Is it moderate enough? Okay. Now let us move on to order and degree of a differential equation. Now, what is order of a differential equation? Order of a differential equation is defined as highest derivative. Nothing but what is the maximum number of time a function is differentiated. For example, you see here, if I just write one differential equation, this is a differential equation because we have got derivative. Now in this, this is the first derivative, nothing but differentiated first time. This is the second derivative, nothing but differentiate twice, and this is differentiate only one. But this power 4 says this derivative is multiplied 4 times. It is actually dy by dx multiplied how many times? 4 times is equal to 7. Now in this, which is that term which is differentiated maximum number of time? It is this we call order of a differential equation. This will give order of differential equation, and this is second order. This is first order. This is also first order. Since this is differentiated maximum number of times, therefore the order will be 2. Now, what is degree? For degree to be understood, first we should understand what is polynomial. Only then the things will be very clear for us. Coming to polynomial, any expression, first let's recall what is polynomial. Kindly pay attention. What is polynomial? Polynomial function. Any expression of the form p of x is equal to a naught plus a1 x plus a2 x square dot then a n x power n, where a n, the highest degree, that is the x power of x is n, its multiple should be not equal to 0, where all a i's are real number. Nothing but a naught, a1, a2 up to n all are real number. So this is a polynomial in terms of what x, and this n is a whole number. I am using the word whole number because here you can see power of x is 1, here 2, here up to n. There is no x here. So I can say that here it is x power 0. So the power is actually non-negative integer. Nothing but it should not be a negative integer. When I say it's not a negative integer, 0 as well as positive integer come into place. Nothing but whole number. Now, here, as you can see, we have a polynomial in terms of x. Similarly, we should have in differential equation, the role of x is taken care by derivative. Before I go ahead, let us take some example here. Now I'm going to give you some example. You are going to comment whether it's a polynomial or not. And when you're commenting, you will mention the number and then you comment. Okay. Let us suppose that we have got, this is first example. This is second example. Third example. Fourth example. Fifth example. Mention the question number and comment. Yes, let us see. You comment till then, I will drink water. Yes, come on. Comment on this example, which is polynomial. Give the number 1, polynomial 2, not a polynomial like that. You give a number. Am I audible? Yeah, I'm audible. Yes, waiting for your response. Okay, Alia is saying example number 1, 3, and 4 is a polynomial, whereas 2 and 5 is not a polynomial. Just mention the question number the way Alia has mentioned, no, like that you mention. Harini, don't take so much time. Okay, no, just if you are going to know. Okay, anyway, I think I might have copied and pasted. Fine. So, yes, what about others? Yeah, see this. Coming to example number 1, whichever we go, first see the definition. Coming to definition, power should be what? A whole number. As you can see, power of x is whole number. Power of x is again whole number. So, and whatever the number is there is a constant obeying this condition. So, first one, second one, and fourth, sorry, first one, third one, and fourth one are polynomials. You are absolutely correct. This will be polynomials. Let me keep the mobile here. Ah, yes, this is a polynomial, this is a polynomial, this is a polynomial. But if you see the power of this is what? Not a natural number, means whole number, therefore it's not a polynomial. Here, if you see, you have got cos of x. Here, you see, that's what, no, here also cos and here also cos. Many will be wondering, here cos is there and here also cos is there. How come this is a polynomial and this is not a polynomial? Because this, you can see, this is free from trigonometric function. Now, one comment will be there, sir, you have got trigonometric function here also, but this is a particular constant. Cos pi by 4 is 1 by root 2, which is a constant, whereas cos x is what? A variable. And this will be, we are going to have an infinite series for cosine, therefore degree will be not defined. So this is not a polynomial function, and hence degree is not defined. The same whatever we have just said, let me take the pen cap. Yeah, so whatever we have just defined, same thing in the place of x, derivative will take the role. Now you see this. This is a polynomial in terms of derivative. And since it's a polynomial in terms of derivative, highest derivative is this, that is 2. And what is the power of this? What's the power of this? 1. Therefore, degree is also what? 1. Okay. Now, with this, let us start with the problems. I hope till here it is clear. Now, I'll be giving the question and I will be reading out the options. I would like you to comment. Okay, in the chat box, when you're commenting, make sure give the question number and send your solution. Okay, now let us start. Yes, good to hear. That's clear. Now, moving on to the question from differential equation, and I have numbered the problem same as the question bank issued by KSEAB. Okay, Karnataka School Examination. Okay, board. Now here, moving on to the first question, the order and degree of the differential equation. The derivative of y with respect to x minus cos x is equal to 0 is. We want order and degree. Options are here. I would like you to involve. I'd like you to involve. Just you can mention Among this, which option? A, B, C, D. Enough. No need to mention this. Okay. Similarly, question number 2, order and degree. Question is this: x into y, second order derivative, plus x into derivative of y with respect to x square minus y derivative of y with respect to x is equal to 0. Again, we want order and degree. I've taken a problem to explain the thing still more clearer. This is the third order, then second order plus e power derivative of y with respect to x. Okay. For this, the options are 1, 2, 2, 2, 2, 1, and option D 1, 1. Whereas for this, the options are, I think for this, instead of giving option, you can just say also order and degree. In that way, we can save the time also. I'll just give one more question here. Come on. At once, we will discuss all this. You mentioned the question number. Again, I want order and degree of this. The thing should be crystal clear. In that way, I have taken the examples. Here the problems. Order and degree problem. Yes. So for all this, we want order and degree. Now let us see what is your comment one by one. I will go ahead with the problems. Okay, coming to question number 1. See here, we have, as I said, the role of derivative. Sorry, the role of x is taken care by the derivative. Here it is first derivative and cos x. Okay, so this is the derivative, therefore it is first derivative. Hence, as it is first derivative, order is 1. And what is the power of this? 1. So therefore, order and degree both are 1. Yes. Alia and Harini, yes, you're right. Whereas coming to second question, as you can see here, they are derivative involved, and this is the second order. And what is the highest power of this? See, this is second order, this is first order, this is first order. So order is always the highest derivative. This is the highest derivative. What is the power of this? Nothing is mentioned. So 1. So order is 2, degree is 1. So 2 comma 1. Order is 2, degree is 1. Coming to this, again you have got derivative, but be careful. Derivative is power of e. This will give you an infinite series. Now, actually, when I make you understand why do we say as soon we have got this, that the degree doesn't exist or undefined. See this. Actually, e power x, the expansion of this is this infinite series. 1 plus x squared by 2 factorial, x cubed by 3 factorial, plus x power 4 by 4 factorial, and moves on. It will be an infinite series. Now, if I have got this much, then what is the degree of this? Power 4. Highest degree, highest power of the polynomial is defined as degree. If I have got only till here, power 3. Only till here, power 2 will be the degree. But here, since infinite and power is always what the whole number is never going to terminate. Okay. So in this manner, I hope it's clear for you that why is that as soon you see exponential function having some derivative, it is what? Degree undefined. And most important than that, this is not a polynomial in terms of derivative. Okay, this is not a polynomial in terms of derivative. Okay, for a while, I'll just come back. Yeah, sorry. Okay, I hope the things are clear. Now, let I repeat again. Whenever we talk about degree, we have to make sure the derivative. Yeah, not muted. Fine. Let I repeat. Whenever we talk about degree of any polynomial, as we discussed, first for degree to exist, the given expression should be a polynomial in terms of that variable. In terms of that variable, here we have got derivative. So the role of x is taken care by derivative. So it should be a polynomial in terms of what derivative. Only then we say it is what it's a polynomial in terms of derivative, and hence degree exists. Now you see this. See, purpose we have taken cos here, then exponential function. You see sign. Why is that? But we don't have derivative, due to which degree exists. So this is the second derivative, first derivative, and this is the one in the function. So because of this, order will be 2 and degree will be 1. Whereas if you see log is there, but who's sitting inside the log? Not derivative. Therefore, what degree is defined. So who's the highest derivative? This. This is the first derivative. And because of this, what is the order? 2. What about the degree? It is 1. And you see again, exponential function is there here also, but here. But this is a polynomial in terms of derivative. Therefore, order and degree. This is the order and the power is 1. So both order and degree both are equal to what? 1. Okay, 1 it is. I hope this is clear. Any doubts? Let us see. Student have commented yes, good. Okay, third one I have just said orally. So coming to third one, what is the order? 3. And what about the degree? It's not a polynomial in terms of derivative, therefore degree is undefined. Undefined. Yes. Fine. Good. Yes. Now let us proceed with the next set of questions. Moving on to the next problem. Yeah. Now let us try to understand what is homogeneous. See, I have not changed the order of the question which is framed by the KSEA board. So sometimes they are certainly going for the other concepts. So let's discuss fast and then we'll go ahead. Homogeneous. When do we say a given function is homogeneous? Homogeneous function. A function f of x comma y is said to be homogeneous if I replace x by lambda x and y by lambda y. I should get f of lambda x comma lambda y should be equal to lambda power n of f of x comma y. Then we say f of x is homogeneous of degree what? Here n. For example, if I give you, come on, comment, see this, f of x comma y. Let us take one problem, then I'll ask you to comment. See here, x cube minus x into y square. Is it homogeneous or not? For that, I have to check. So replace what by what? The x by replace x by lambda x and y by lambda y. If we do so, we are going to have from here f of lambda x comma lambda y, which will be lambda x cube is there, so I can give cube for both. Then minus in place of x lambda x, in place of y lambda y, and we have a square, so whole square. So you are going to have lambda cube x cube minus lambda as it is for a while. Yeah, lambda as it is, x as it is, squares for both, so I'll get lambda square, then y square. Lambda into lambda square will be lambda cube, x into y square, and here we have lambda cube x power minus 3. Common is what? Lambda power 3. So you get x cube minus x into y square. So this we can see is present here. Correct? Nothing but f of x comma y. This is actually the usual procedure. Usual procedure which we are going to avoid, but now method is something like not important. Every method is important. There will be a scenario where we'll be checking in this procedure, means the procedure which I'm going to give you shortly. We may surely stuck, but this will never fail. And this will be a homogeneous for homogeneous function. The condition should be this, that if I replace x by lambda x and y by lambda y, I should get back this expression. So after doing that, we can see in place of n we have got 3. Therefore, this is homogeneous function of degree what 3. Fine. Now, what is the other way? Very simple. Just see, whenever you have got product of two terms, use law of exponent. Treat both x and y to be same. I repeat, use law of exponent and treat. I'm giving a short trick. How are you going to? Just by seeing, analyze whether the given function is homogeneous or not. So here, I'm copying the question, and if you see very clearly, here the power of x is 3. Okay, keep as it is 3 in your mind. Now here is a product of two variables, so recall law of exponent. A power m into a power n is a power m plus n. Correct, no? So whenever bases are same, we can add the power. So treat both x and y to be same variable. So here the power is 1. 1 plus 2 will be 3. Here also 3. Here also 3. Therefore, it's a homogeneous of degree 3. I hope this logic is clear. Kindly comment. And I would like you to first comment, is this clear? Okay, good to hear. Now having understood this, homogeneous of degree n we have got, but coming to our homogeneous differential equation, homogeneous differential equation, hence for the right DE for differential equation. Whatever we are going to have any homogeneous differential equation, we are having a condition that it is only for degree 0. Nothing but if I'm able to express the given question in this form, x by y, better y by x, y by x. Now see carefully, when adding y by x, there is no multiple here. And here power is 1, here also 1. Nothing but homogeneous of degree 0. Only for homogeneous of degree 0, we are going to have solution under homogeneous differential equation. That you have to remember. It's not for any arbitrary. Okay, that's what you can see. Whichever problem is given in our notes, it is derivative of y with respect to x. Nothing but PUC, y plus x divided by y minus x, for example. See the power of this. Come on, tell me what is the degree of this differential equation, homogeneous differential equation. What's the degree with respect to homogeneous? No one? Okay, let us come in now. Here, yes, I'm asking homogeneous. This is a homogeneous differential equation of which degree? Yes, sir, I'm asking what will be the degree of this for homogeneous? Homogeneous of what degree? Till I guess this. Yes, I'm waiting for your comment. Yeah, degree is 0. Yes, you are right. Degree is 0. And again, you can just see by the short trick which I gave. See here, power of y is 1. Okay, 1. Here also power of x is 1. Okay, so both are, see, as soon you see in between them plus or minus, you should separate them. Whenever you have got product, then you have to add them. So here also power 1, here also power 1. So on the whole, numerator power is what? 1. Denominator is what? Power 1 for x, for y also. I repeat, for y also 1, for x also 1. So now denominator also power 1. So now think as law of exponent. What is a power m divided by a power n? It is a power m minus n. So numerator power is what? 1. Denominator power is what? 1. When it goes to numerator, by using law of exponent, we'll get minus 1. 1 minus 1 is what? 0. Therefore, it is homogeneous of degree 0. Yes, you're absolutely right. Now let us move on to the problems. Kindly, I will read the question. Question number 24. Listen to the question and respond. Question says a differential equation of the form derivative of y with respect to x is equal to f of x comma y is said to be homogeneous if f of x comma y, if x of x comma y is a homogeneous function of degree. This is homogeneous function of degree. Option 1, 0, 2, 2 not defined. Yes, comment on this. 24th B. Yes, Alia has responded 24th B. Yes, Alia, you are right. And you have to remember, coming to homogeneous differential equation, as soon we say it's homogeneous differential equation, the degree is always 0. Okay, this is not going to go for more than what? 1. And I want you to understand this. I mean, again, I repeat, degree should be always 0. It's nowhere even equal to 1 for homogeneous. Now, here's some of the things to be clarified. First, if I talk about differential equation, order and degree both are natural number. They are not 0. Talking about differential equation. Talking about homogeneous differential equation, degree start from whole number 0, 1, 2, 3. So our homogeneous differential equation degree is always what? 0. Okay, fine. Now let us move on to the next question. I hope this is clear. Now you are going to comment question number 27. I'm writing which of the following is homogeneous. You can only mention the option. Which of the following is homogeneous? Write the options. For x, you have to comment which of the following is homogeneous. And now you'll understand the benefit of shortcut. First option is this. Second option. Third option is this. Then lastly, the fourth option. Yes. Which of the following is a homogeneous? Which among this is homogeneous differential equation? You have to comment. Okay. Let's see. Option D. Option D. Yes. Yes, you're right. Question number it is. Yes, yes, yeah, you're right. It is question number 28. Oh, good. She's kept question bank in front of her, so I can't escape from her. Okay. So as you can see here, as we said, went for the shortcut. Here, see, power of x is 1. Here also, y power is 1. In place of in between them, you have got plus, so you have to separate. But here there is no variable, nothing but the power of the variable is what? 0, because again this has x power 5 into x power 0. So this is not homogeneous. As it is not homogeneous, no need to go for next. Again here, power of x is 1, power of y is also 1. It's a product of two terms, so I can just say 1 plus 1 is 2. But here power of x and y both are what? 3. Again, this is also not homogeneous. Both are not homogeneous. Here power of x is 3. Here it is 2. Oh God, here it is over. Game over. Not. But you see power of y 2, power of x 2. Here power of x and y 1 plus 1 will be 2. Here also 2, 2, 2, 2 everywhere. Therefore, it's homogeneous. In no time, we can get the answer. Okay. I hope this is clear. Now, let us move on to how are we going to solve this homogeneous differential equation. What was the procedure? See, we are going to write homogeneous differential equation in the form whichever the differential equation is given. Let us suppose we have got f of x comma y in the form of two variable. We are going to express the given differential equation as g of y by x. Correct? And then we are going to take y by x is equal to u, and then we are going to cross multiply y is equal to u into x, and then we are going to differentiate, and it after we substitute back here, it will reduce back to variable separable method. This is type 1. Type 2. Okay, this is type 1 will take. Fine. Type 1, this is 1. Type 2. Let us suppose that I have got a differential equation, but on simplification, I will be getting this to be what? X by y. And due to which my derivative will be derivative of x with respect to y. Then we are going to take x by y is equal to some variable v. Then cross multiply here, x is equal to y into v. We are going to differentiate with respect to y for this, and then we get the variable separable procedure. We are going to obtain and get the answer. So these are the two ways for which we have got for homogeneous to solve. Now on this, let us take one question. Before I take that question, I want you to recall one important point. There are 4 points. See carefully. Listen carefully. What is, if I take differential coefficient d, differentiation of x plus y will be differential of x plus y will be differential of x plus differential of y. So minus here, then a minus. Then if we have got differential of x, okay, then saying yeah, fine, x into y, product rule. So here this x is first function, y is the second function. Keep y as it is, differential of x, then plus keep x as it is, differential of y. Next, if you have got differential of y by x, nothing but I have to apply quotient rule. So here we are going to have square of the denominator, because x is denominator. Keep x as it is, differential of numerator y minus then keep y as it is, differential of denominator. It can be this, or we can also have differential of x by y. So square of the denominator. So keep the denominator as it is. Differential of numerator, that is dx, I'll get minus. Then keep x as it is. Differential of y is what? dy. We should know both the side, left to right and right to left. Okay. So now let us take one question on this. The question is question number 30. It says the general solution. Now, what is general solution and particular solution? First, let us understand what is solution there. See, as you know, if I ask you what is the root of this, come on, say me. What is the solution of x plus 8 is equal to 0? X plus 8 is equal to 0 solution. X plus 8 is equal to 0 solution. What is the solution? Yeah, x equal to minus 8. So you have just solved this, correct? Similarly, coming to differential equation, let us suppose I have got any differential equation given here. Now, what is the solution of this? It is any function as a y equal to f of x comma y, which is going to satisfy this differential equation. Which is going to satisfy this differential equation. This we call integral curve or solution curve. Now, this will have two categories. What? This solution, if it involves some arbitrary constant, then we call it as general solution. Let us suppose the same solution, in place of arbitrary constant, we have got a fixed constant, any fixed constant, let us suppose 7 here, then we call it as particular solution. Particular solution. Here I have given purposefully 7 here. Okay, I can just have a statement that any solution free from arbitrary constant is known as particular solution, and any solution containing arbitrary constant is known as general solution. Actually, we can get particular solution from general solution by assigning a particular value for C, which will be stated in the question there. Okay, so having this, and one more thing you should understand, that order of the differential equation will depend on number of arbitrary constant. If I've got 3 arbitrary constant, after simplification, then the order will be 3. If I've got 1 arbitrary constant, after simplification, I'll be having only the order to be only once. Whereas coming to particular solution, as there is no arbitrary constant, as soon as you differentiate a particular solution, you will get the differential equation, and hence order will be what? Always 1. For particular solution, we can always say the order is always 1, because as soon you differentiate, for example, if I give you like this, y is equal to x square plus 2, and I want what? Differential equation of this, or I want differential equation of this. Just I have to differentiate derivative of y with respect to x is dy by dx. X square will be 2x. Derivative of 2 is what? 0. So we are going to have only 2x. So this is our differential equation where the order and degree is what? 1. Whereas in the general solution, the things are not same. We have to count how many arbitrary constant is there. Depending on that, we are going to have a general, I mean to say, general solution will give us the order of the differential equation depending on how many arbitrary constant is there. For example, let's suppose I've got, let's take it here, y is equal to mx plus c. How many arbitrary constant do we have? 2. Therefore, we are going to have a order to be 2. Then I work out and make you understand how it is so. How come I said order will be 2? See, when I said differential equation, it should be free from arbitrary constant. If I differentiate this, we are going to have derivative of y with respect to x is equal to m as it is, scalar rule. Derivative of x is 1 plus c is a constant 0. So derivative of y with respect to x is equal to m into 1 is what? M. Now, this is not a differential equation still, because I have got arbitrary constant m, which is slope of the line. This is equation of line in the slope intercept form, or better, y-intercept form. I mean to say y-intercept form. Now, this is not a differential equation. So if I think of substituting the value of m here, then what I'm going to get? Y is equal to m value is derivative of y with respect to x into x plus c. Still, because of the c, it is not a differential equation. So I am forced to again differentiate this. If I again differentiate this with respect to x, this will be derivative, the second derivative is equal to derivative of m is a constant, so it is what? 0. So how many arbitrary constants we had? 1, 2. Therefore, the order is also what? 2. So in general solution, as soon we are aware about how many arbitrary constant is there, we can always talk about what? Order of the differential equation. And coming to solution, we have got two types: general and particular. Coming general, arbitrary constant, and particular, no arbitrary constant in that particular solution. I hope this is clear. Now let us take the problem. Am I too fast or the speed moderate? I have to be slowing down. How it is? Kindly comment. Are you clear with this concept? Okay. Now let us take the problem. Question number 13. Come on. I want the solution of this. The general solution of y dx minus x dy whole divided by y is. Options are xy is equal to c. Option B, x is equal to cy square. Option C, y equal to cx. Option D, y equal to cx square. The general solution of this we want. Yeah, just comment till then and drink water. Yes, what's the answer for question number 30? Y equal to cx. Nothing but option C. We'll see what about rest. Okay, even Alia says y equal to cx. Yeah, just see here. Now this one, as you can see, there's a difference here, and there's a denominator y. You can see it is going with this. Only for quotient rule, you have a minus, and always you see carefully the one no which is having plus sign, that is there in denominator. Nothing but different quotient rule concept. So here what I can do is divide by y on both the sides, so that I can have y square in denominator. So when I say divide by y into y will be y square. Then you have y dx minus x dy is equal to 0. Now I'm going from right to left. So this is same as this. So I will get derivative of differential of x by y is equal to 0. So on integrating both the sides, we are going to have so both differential and integration will come out. So we are going to have x by y is equal to the constant cos multiply x is equal to c into y. X is equal to c into y. X is equal to c into y. We don't have. Doesn't mean that answer is wrong. C, we have to match with the option. C, can't I cross multiply? I'll take this concept with some k. K, okay. Now if I cross multiply, we'll have y is equal to x by k or 1 by k. So 1 by k I can take as c, where c is what? 1 by k. So y equal to cx is an option C. So constant we can take always, we can play with the constant. So can we also cross multiply? What happened? I think some comment Harin is sent. Have you deleted the Harin that comment? Okay, if you want to cross multiply, yes. If you cross multiply, then see you are going to have y dx minus x dy is equal to 0. Then I have to divide by x into y. Y by y will get cancelled, get 1 by x minus x by x will get cancelled, get 1 by y. So here dx and dy. Now you have to integrate. You'll get log mod x minus log mod y. Can I complete that? Yeah, in this way also you can do it. So just see here. After we have divided, see on integrating from here, the alternate procedure. 1 by x dx minus 1 by y dy is equal to 0. Integration. Integration of 1 by x is log mod x. This will be minus log mod y. Constant will be log c. So now very clearly, I can just say that log of mod x, if I transpose, okay, log m minus log n. What is log m minus log n? Log m by n. So I can have x by y is equal to log c. Now I can equate this term under the log x by y is equal to c. Cross multiply, we are going to have x is equal to y into c. Again, c you can cross multiply, then what you will get? Y is equal to, let us say the constant again, what? K. So I'll get y is equal to 1 by k times of x, which is same as y is equal to 1 by k. I'll take as c, x. Yeah, option C again correct. This way also we can do, Harini. Is that clear, Harini? Now moving on to next. But better to remember what I just erased, okay? That will be also a handful result for us. Now I am reading one question. You are going to answer this. The number of, okay, so fill in the blanks question. Listen the question carefully and answer. This is question number 31. All right. This is question number 31. It says the number of arbitrary constant in the general solution of a differential equation of fourth order are. What's the answer? Fill in the blanks. I repeat, the number of arbitrary constant in the general solution of a differential equation of fourth order are. Let us see in chat box what you have said. Alia says 4. Okay. What about rest? Yes, Alia, you're right. See, they said they have got in the general solution how many? What's the order? 4. Since order is 4, number of arbitrary constant of any general solution should be same as order of the differential equation. Similarly, as soon the order is some n, the general solution should have a n arbitrary constant. Okay, yes, you are right. 4 is the answer. One more thing, I know when I just went through all the problems for 1 marker, they have not as any variable separable problems. Okay. Now we have got this integral factor. Let us recall linear differential equation. See, presently we are dealing with the methods of solving first order, first degree differential equation. Order also first, degree also first. So let us recall what is this linear differential equation. linear differential equation. So we have got two categories here. First one, let us suppose I've got differential equation of the form derivative of y with respect to x plus py is equal to q, where both p and q are functions of x alone or a constant. Then here, to integrate this, we have to first find the integral factor, which is e power integral of, make sure derivative of y with respect to x multiple is 1. Then y multiple we have to take under integration and find the integral factor. Then we are going to find general solution. The general solution, in short, which we call as GS, I call as GS, will be y into integral factor is equal to integration of, again, the integral factor into the right hand side q. This will be the complete solution. You should know the method also. Who knows, they may ask a problem on method or the p and q is a function of the independent variable x alone or a constant. Now in this we have got one more form. This we can take as type 1. In this we have got one more form. Where's the marker? It's here. Now coming to type 2. See, in type 2, here as you can see, the independent variable is what? X. It can happen that the independent variable is what? Y. So derivative of x with respect to y plus p1. See, here got y. Now it is x is equal to q1. What you can see is the role of y is taken care by x and the role of x is taken care by y. Okay, x role is taken care by y. So now the both p1 and q1 are functions of y alone or a constant You have to understand, when I'm saying x alone, it is with respect to the independent variable, that is x here, and here the independent variable is what? Y. So now how are we going to find integral factor? It will be e power integral of x multiple p1. So p1 with respect to y. Then the general solution is given by, again you see, simple, wherever y is there, replaced by x, and wherever x is there, replaced by y. So y was dependent variable, now it is x. So x into integral factor is equal to integral of integral factor into q. So since I have got q here, so it is q. Okay, be careful, it's a comma here, it's not 1. Okay, so q1 with respect to y. So both the types I have discussed, and from this you are also going to have 5-marker question. Don't forget that. So now let us move on to the problems on this. Now be ready for the problems. Now it's your turn. I hope my students are ready. Now the question for you is question number 33. The integral factor the integral factor of the differential equation x derivative of y with respect to x minus y is equal to 2x square is. So they are saying that the integral factor of this question is k divided by x square. Okay, k divided by x it is. Okay, then we have to find k value. Come on, get me the answer. Similarly, write one more question here. Just mention question number and k value. Then question number 34, we want integral factor of the differential equation. We want integral factor. Differential equation is this. Options are given for 34, but you can get the answer. Then 35 also we can take. Let's see what's the answer we have replied. Yes, no one answering. Okay, let's solve now. Alia says it's 1. K value is 1. Let's see. See, coming to the differential equation, let it be type 1 or type 2. Yeah, here. The linear differential equation. Our dy by dx multiple should be 1. Here also dx with respect to y should be equal to 1. Its multiple should be 1. Here you can see it is x. So first divide by x to make it 1. As soon as I divide, x by x will get cancelled. Derivative of y with respect to x minus 1 by xy is equal to x square by x will be x, no? So I'll divide toward by x. Now if I compare this with this, see y multiple is p. So what is y multiple? Minus 1 by x. So p is equal to minus 1 by x. So I want the integral factor. So integral factor will be e power integral p dx. What is p value? Minus 1 by x with respect to x. What is integral? Okay, let us write a bit more clearly. Space not sufficient. Yeah. So integral factor will be e power integral p. What is p? Minus 1 by x with respect to x. Integration of 1 by x is log mod x. And here we have a minus. Recall the property of log. What is k log m? It is log m power k. So in place of k, we have minus 1. So we are going to have e power log mod of x whole power minus 1. And we know one property, what is a power log of f of x to the base a. Whenever the log base is a and this entire expression base is also a, that is what the f of x. So you can see now the entire expression base is a. I mean to say the entire expression of this term is e and base of the log is also e. So I'll get this one to be x power minus 1, nothing but 1 by x. So in place of k, what do we have? 1. So k is equal to 1. Yes, you are right, Alia. Now moving on to next problem, question number 34. Let us solve this. See carefully. Pay attention. See again, no. First, make sure this multiple should be what? 1. Here we have dx by dy. Derivative multiple is what? 1 minus y square. So divide by 1 minus y square on both the sides. When I do that, I'll have 1 minus, okay, I'll have directly here. 1 minus y square by 1 minus y square is what? 1 into dx by dy plus y divided by 1 minus y square into x is equal to ay divided by 1 minus y square. Now, let us find the integral factor. This is exactly going with the second type. In place of p, see, p1 multiple is x. Yeah, this entire multiple is what? X. So my p1 value will be this. p1 is 1 minus y square. Now the integral factor will be e power p1 dy. Correct now? Oh, 1 divided by, sorry. I mean to say what is p1? y divided by 1 minus, the entire thing is what? P1. So y divided by 1 minus y square. So e power integral y divided by 1 minus y squared with respect to y. Now we have to integrate this. Now, no need of method of substitution. In integration, we have one logic and trick for able to erase this. Let us make some space. So no one has answered still this question solution still. See carefully now. We have one result. What? Integration of f dash by f dash of x by f of x with respect to x is what? Log of mod of f of x plus c. That logic we can use. Let us copy this again here. E power y divided by 1 minus y square dy. Now see, what is derivative of 1 minus y square? Derivative of 1 minus y square will be 1, that is what, 0, minus y square will be 2y. Nothing but I'll get minus 2y. We have only y. So what we can do is generate this term in numerator. So multiply by minus 2, divide by minus 2. Okay. Then 1 minus y square with respect to y as it is. This is the power of e. Now see carefully, pay attention, listen carefully. Derivative of 1 minus y square is minus 2y. So this is your f and this is your f dash. So what is integration of f dash by f? Log of mod f. So here we are going to have e power minus half and integration, this is a series, f dash by f is log mod f. So f is what? 1 minus y square. So log of mod of 1 minus y square. Now recall, what is k log m? It is log m power k. So in place of k we have minus half, so I can just take it to the power of m here. It is 1 minus y square power. So we get e power log of 1 minus y square whole power minus half. Then recall the property, what is a power log of f of x to the base a? Answer is f of x. So again the base of log is what? E. This also e. So we are going to have this one to be 1 minus y square whole power minus half. Or I can write 1 divided by 1 minus y square whole power plus half. By using law of exponents, I have taken negative to denominator. Then this is the other way of writing, this will be 1 by square root of 1 minus y square, because power half means square root. Let us see the option. This time no one have answered. Okay, so the answer for this is option D. Before proceeding, any doubt? Is it clear? Dear students, is it clear? Okay. Now let us move on to next. Now the next question is, okay, question number 35. The integral factor of the differential equation. Question number 35. The integral factor of the differential equation e power x dy plus y e power x plus 2x into dx is equal to e power dy plus y e power x plus 2x. Yes. integral factor of this we want. So let's solve it. See carefully. Again, first to know, always prefer the first one, that is type 1. If you are not able to get, then you will take reciprocal, then you will get type 2. Now, if I divide by dx, see, I want dy by dx form. dy by dx. See, I want in this form. dy by dx plus py is equal to q. So first I want dx in denominator. Here it is there. So I divide by dx and dy by I repeat dx. Okay. And dy by dx multiple is 1 here. But in place of that we have an e power x. So I'm multiplying by this both term. Means I'm dividing, I mean to say. When I divide, e power x by e power x will get cancelled. So I'll get only derivative of y with respect to x plus y e power x plus 2x whole divided by e power x, and dx by dx will get cancelled, is equal to 0. Now e power x want to divide both. Come on, divide this. Derivative of y with respect to x plus y e power x by e power x plus 2x divided by e power x is equal to 0. E power x got cancelled. Derivative of y with respect to x plus y, okay, is equal to, I can transpose this, I'll get minus 2x e power minus x. We want integral factor, and you can see very clearly this is expressed in the form 1, the type 1. So if I compare with the type 1, we are going to have derivative of y with respect to x plus py is equal to q. So p is multiple of y. Here y multiple is what? 1. So p is equal to 1. So the integral factor of this will be e power integral p dx. So e power integral, what is p value? 1. Integration of 1 with respect to x is what? X. So e power x. Let us see which option. 35. So they asked the integral factor is e power kx, then what is k value? So if I compare with e power kx, very clearly k is x multiple, and here what is x multiple? 1. So k is equal to 1 will be the answer. Fine. Now moving on to next. Question number 40. The order of a differential equation. I would like you to answer this. Question number 40. The order of a differential equation whose general solution is y equal to a sin x plus b cos x. So the order of the differential equation whose general solution is this, and here a and b are some arbitrary constant. So what could be the order of this differential equation? You have to quote about the order of the differential equation. Okay. See here, we have two arbitrary constants. So as we discuss, order of the differential equation will depend on arbitrary constant, which is given in the general solution after simplification. So you cannot further divide when simplify this. So we have got, since we have got two arbitrary constant, therefore order of the differential equation will be 2. Order of the differential equation will be 2. So for question number 40, the answer is option blue, B. Now question number 42 is assignment. Now we are heading with the last problem, question number 43. I mean to say question number 45, not 43. I will read the question. It's a statement, means assertion reason type question. See, let us first understand what is this assertion reason type question. Most of the time, students will have a doubt on this. See, coming to assertion reason type question, there will be two statements given to you. Problem for the student is if both the statements are true. If the both the statements are true, no, we are going to have two options. The option will be like this: statement one is given to you, statement two is given to you, and another suppose both statement one and statement two is true. Then in option no, there will be two options challenging one for you to judge among these two which is true. One of the option will be statement one is true, statement two is true, and statement two is a correct explanation for statement one. What? Statement 2 is the correct explanation for statement 1. Whereas one more statement means one more option will be statement 1 is true, statement 2 is true, and statement 2 is not a correct explanation for statement 1. Not a correct explanation. Okay, so now how to know which one is correct? See, whenever you are going to use the fact of statement number 2 to get the result of statement number 1, I repeat, whenever you take the help of statement number 2 to get the answer of statement number 1, only there is a correct explanation, otherwise no. Okay, now let us go for the problem there. Question says, question number 45, there are two statements here. Statement number 1: a function that satisfies the given differential equation is called its solution. What do you think? Is it true or false? A function that satisfies the given differential equation is its solution. Yeah, that's what we discussed at the beginning. Any function satisfying the given differential equation is the solution of that. And in that we have got two categories: general solution and particular solution. So statement one is true. No problem with the statement number one, it is true. Coming to statement number two, order and degree, if defined, of a differential equation or of a differential equation are always positive integer. Yeah, order and degree are always what? Positive integer. True. Now, statement number one, statement, I mean to say option number A. Option A is statement one is true and statement two is false. Option B, statement 1 is true and statement 2 is false. I repeat, option B, statement 1 is true and statement 2 is also true. Option C, statement 1 and statement 2 are false. Option D, statement 1 is false and statement 2 is true. Here they are not asking about anything, no correct explanation or not. So anyway, here the option B is correct because both are true. So with this, we come to an end on differential equation. Then I drink water. Then we'll start with next part. Okay, dear students, now we'll head over to the next chapter, relations and functions. Okay, now let us move on to relations and functions. Can anyone define what is a function? Or can anyone define what is reflexive relation? Yes, comment. Now, let us move on to relations and functions. What is a relation? See, it is a special type of function where I repeat, what is a relation? Relation is a subset of Cartesian product A cross B. So each element of the relation R will be an ordered pair of the form x comma y. Okay, where the x will come from the first set, y will come from the second set. But coming to types of relation, it is A to A. Here it is A to B. It will be always A to A. Now in this week, let us recall types of relation. Coming to types of relation, we have got the first one to be coming to the heading types of relation. Types of relation. In types of relation, the first one is empty, or I can say void relation. Now, what is empty or void relation? It is a relation in which none of the element obeys the given relation. So, in that case, R will be equal to empty. Next, universal relation. Now, what is universal relation? Universal relation. A relation R is said to be universal if each and every element of the set A is related. Okay. So then in that case R will be equal to A cross A. And this too we call trivial relation. Trivial relation. Okay, we don't have much problem on this, but don't ignore. Okay, always will be very handy. Next comes reflexive relation. Coming to reflexive relation, both in the order pair, both first element and second element should be what same, and it should happen for all the element in the given set A. Only then it is what reflexive. And here I would like to say on a set A, on a set A. So first the set A should be given, and then we have to talk about types of relation. Next comes fourth one, symmetric relation. Coming to symmetric relation, if we have got A comma B belongs to R, this implies ulta of this. What is ulta of A comma B? B comma A should also belongs to R. So understand here, to come here, no, first this element should be present. If condition should happen, then I should go for search. This is in, this is out. So to come out, no, to have out, no, think like this. To have out, no, first I should have in. Okay, the first if condition should be satisfied. Okay, now moving on to the next is transitive. Coming to transitive relation, if we have A comma B belongs to R and B comma C also belongs to R. See this carefully what's happening here. These two are same. In the first order pair, second element, and in the second order pair, first element, both are what same. Then A to C should also happen. A comma C should also belongs to R. Only then we say transitive. There is one more alternate thing to remember. What? Let us suppose I have got A comma B belongs to R only. Purpose is only. Nothing but what? See, as I said here, no? To come here, I should have first this. First, if condition should be present, only then I'll check for the then. He said, no, if I go to college, then I will attend the class. Without going college, you cannot attend the class, correct? No. First, you should be moving to college there. Similarly, first, these two conditions should satisfy. Then I will search for A comma C. But if this element is not there, then I not search for A comma C. I repeat, if A comma B and B comma C is present, then I will search for A comma C. If A comma C is present, then it is transitive. If A comma C is not present, it's not transitive. Clear? Okay. But searching for A comma C depends on what? These two should be present. But let us suppose this is not there, nothing but this case. Whenever it is only A comma B, then there is nothing to search for A comma C. A comma C, nothing to search. So this is not going to contradict the definition. Hence, it will be what? Transitive always. It will be transitive. And any relation obeying the reflexive, symmetric, and transitive, this we call as the equivalence relation. Equivalence relation. Okay, fine. Now, here I just want to take one more. No, one relation is the identity relation. You might have surely heard in first PUC identity function for 5 marks. The first graph for 5 marks in chapter relations and functions. So identity relation. What is this identity relation? A relation is said to be identity relation if it is a set of, see the carefully, it is set of all ordered pair where both the elements are same. For all the element present in set A. Understand the difference of this and this. Here also I am saying that A should belong to capital A. Here also A should belong to capital A. Here both should be same present in R. Here also both, but here I'm saying I want only that element. Here I can have extra also other than this. For example, if I say A is equal to 1 2, then you see R1 is 1 1 2 2. Let's suppose R2 is 1 1 2 2 and lastly 1 2. Okay. Now first is R1 reflexive. For reflexive, whatever the element of set is there, that should be repeated. 1 and 2. Yeah, 1 1 2 2. Therefore, this is reflexive. Here you see 1 1 2 2. Yeah, it is reflexive. So both are what reflexive. But coming to identity relation, it is set of all the element in which both the element of the order pairs are same. Only those elements I want. If you see R1, yeah, both the elements are same and both are present in A. Therefore, this is a identity relation. So I will ensure I let IR, okay? Identity relation. So this is identity relation. But if you see here, apart from this, we have this extra term. So because of this extra term, it is not identity relation. So we can say that identity relation R1 is subset of R2. So every identity relation is subset or equal to reflexive relation. Okay. And one more thing you see is carefully. Check. I would like to say, I'd like you to comment. What do you think about R1? What do you think about R1? Which type of relation it is? I would like you to comment. R1 is which type of relation? Yes. Anyone? Can you say me R1 under this reflexive symmetric transitive, which type it is? Mm. Yes. See, every identity relation, I would like to comment here. Every identity relation, that is this, is equivalence relation. Equivalence relation, I'll take small e cap, in short ER. Why it is equivalence relation, sir? Try to understand. First, it is reflexive, yes. Coming to symmetric, whatever you say, ulta should be there. Ulta of 1 1 is 1 1 itself. Ulta of 2 2 is 2 2 itself. Therefore, it is symmetric. And see the transitive. It is not going with the first definition, it's going with the second definition. 1 comma 1 only, 2 comma 2 only. So every identity relation is not only equivalence relation, it is also smallest possible equivalence relation. Smallest possible equivalence relation. And in this, you see, set A had two elements. And for a relation to be a smallest possible equivalence relation should have how many ordered pair? You should also have two ordered pair. So ordered pair of the smallest equivalence relation will depend on number of elements in set A. If it has got n elements, it should have n ordered pair minimum to form an equivalence relation. Now here we have spoken about minimum. Then what could be the maximum number of elements in the relation to be the biggest or the largest equivalence relation? Come on. What could be the biggest or the largest equivalence relation? Let us see who will comment. Who is the biggest or the largest equivalence relation? Yes, which is the biggest? Yes, you're right, Manikandan. It is universal relation. Yes, you're right. It's a universal relation. As you know, universal relation is same as what? A cross A. A cross A will have all the elements of the relation. So the biggest will be universal and the smallest will be an what? Identity relation. So having this, let us proceed with the problem. Now, from this question number 2, I'm going to read the question and along with the option, let me know the answer. Both empty relations and universal relations are option A, empty relations, option B, universal relation, option C, trivial relations, and option D, equivalence relations. Anyway, I have already said the answer here. Trivial relations they are. Trivial relations they are. Therefore, for question number 2, option C is correct. Option C is correct. Now, I'm getting question number 7 here. Question number 7 says a relation R in the set 1, 2, 3 given by R is equal to 1, comma 2, 2, comma 1, 1, comma 1 is. Which type of relation it is? Options are talking about symmetric, reflexive, and transitive. Come on. See this relation and comment which type of relation it is. I'm waiting for your response. Okay, let us move on. See carefully. Alia says symmetric but not transitive. Let's check. See, first, is it reflexive? What about reflexive? What about reflexive? Is it reflexive? I know many students will be seeing this element and they'll comment it is reflexive. No, come to reflexive element. Both first and second element of the order pair should be same, but should happen for each and every element in the set A. So set A contains 1, 2, 3. So it is not reflexive because 2, 3, 2, comma 2 and 3, comma 3 does not belong to R. Therefore, not reflexive. Coming to symmetric, what should happen? In symmetric, we should happen if A comma B is there, ulta should be there. So what is 1 comma 2? Ulta 2 comma 1. 2 comma 1 ulta is 1 comma 2. Ulta of 1 comma 1 is 1 comma 1. So it is, yes, it is symmetric. As 1 comma 2 belongs to R, even the ulta of that is what? 2 comma 1 also belongs to R. Next, coming to transitive. See, coming to transitive. See carefully. What about transitive? What's the comment about transitive? See, if you go from here, first and second, it looks like 1 comma 2 belongs to R, and let's keep the mobile here, and 2 comma 1 also belongs to R. So coming to transitive, as you know, B here same, then A comma C. Yeah, see, this 2 and 2 are same, so I want 1 comma 1. So this implies, do we have 1 comma 1 present in R? Yeah, it is present. It looks like it's transitive, but you have went for with respect to this 1 comma 2 and then 2 comma 1. Now start with 2 comma 1. If 2 comma 1 belongs to R and 2 comma 1, then 1 comma 2 also belongs to R. These two are same, so we expect 2 comma 2. But do we have 2 comma 2 here? No, we don't have 2 comma 2 belonging to R. Therefore, not transitive. It is not transitive. It's only symmetric, neither reflexive nor transitive. So, which option? Question number 7. Yeah, symmetric but not transitive. Option B. Yes, Alia is right. So in that option, reflexive part was not mentioned, so she has not commented. Now moving on to question number 11. If a relation, question number 11 I'm writing here. If a relation R on the set 1 comma 2 comma 3 defined by R is equal to 1 comma 2, then R is option A reflexive, option B symmetric, option C transitive, option D none of this. Come on, let us see who will use the brain. What is the comment? As you can see here, we have only one element. It can't be reflexive because 1, 1, 2, 2, 3, 3 is missing. Correct? And it can't be symmetric because 1, comma 2 is there, but 2, comma 1 is not there. It is only transitive, nothing but only. No? This definition is obeyed. In short, every singleton relation is transitive. Singleton means having only one element. So, as a note, we can remember every every singleton relation is transitive. A very handful result. Okay. Let's move on to next. So this is only transitive. So which option for question number 11? Option Bablu. Next question. Uh, it's on perpendicular. Question number 12. This will be assignment and it's NCERT problem. So I'd like to take question number 14. Let W be the words in the English dictionary. Define the relation R by R is equal to, the relation is defined like this. It's an ordered pair X comma Y belong to W cross W such that the words X and Y have at least one letter in common. One letter in common. This is the relation given by them. And what else? Then R is, they are talking about types of relation. So here the set here is the W. It is in terms of here. W is set of English dictionary, words in the English dictionary. So words in the English dictionary, that is our set W. So in place of here they are given W, which is set of words in English dictionary. Now I have to go one by one. I have to talk about types of relation, and the correlation is here X and Y. If I take two letters, X and Y should have at least one common letter in common. Okay, at least means what? Greater or equal to minimum one letter should be common. First, coming to reflexive. Coming to reflexive, you can see if you take any letter of your choice. Let us suppose cat. For reflexive, what should happen? Both the elements should be same. So again, if I take cat, what is happening here? Three letters are common. That will happen for each and every element. See, if you take one word, each and every word is same as itself, correct? No, same to itself, and but common, and it is happening because it is reflexive. So yes, it's going to be reflexive. As here, I can just write whichever word I can take. Not only cat here, I just took as an example. I can just say that x comma x, and what is going to happen? X and x will have a same common letter. Okay, therefore it is reflexive. Coming to symmetric. Coming to symmetric. Think in terms of example. If x and y will have, if x and y, okay, belongs to, if I take x comma y belongs to R, then what will happen? X and y will have at least one letter in common. One letter in common. One letter in common. So it also implies when x and y will have one letter in common, it also means that y and x also have at least one letter in common, due to which y comma x belongs to R. This implies R is symmetric. What about transitive? That will be very interesting. Very interesting. I'll just erase this side. So all should be now remembered by now. Smallest sequence relation, the largest one. See carefully for that transitive. Think in the form of example. Here there was no enough example because when xy is there, surely ulta is also there, common. But here we have three elements. No, see this. Think of some example. Suppose now I'll take cat belongs to R. Then I have to take such a word that one word should be common so that I can have A comma B. So it's something like top, T is common. Then so wait, write properly. This is actually not in this, it is in W. Okay, it's in W. So this implies that cat comma top belongs to R because one letter is common in the word cat and top, T. Now I can take one more, no, such a way that it's common, one letter is common but should not be present here. What could be that? Oh yeah, P-I-C-K, pick. Yes, see carefully. P is common here. So here and top comma pick belongs to R, but see these two are same. That's what no transitive. B and B same, but A and C should not be. It should be present or not. We should check. But A, that is cat and pick, not even a single letter is common. So it is not obeying the relation. So cat comma pick will not belong to R. This implies R is not transitive. Is this clear? So which option it will be? Which option? Question number 14. reflexive, symmetric, but not a transitive, option blue. Okay. Now let us proceed with the next. Okay. Now moving on to the next problem. Question number 19 says, question number 19 says, let R be a relation on the set n of natural number defined by, so the set A. See, as you know, for any set, any relation, we should have a set. So the set A is a set of natural numbers. So A is equal to set of natural number. We know so counting number 1, 2, 3 moves on. So what they are saying is the relation. Okay, let R be a relation on the set n of natural number defined by n is related to m if n divides m, not divisible, divides. Divide means what? N divides m means what? This implies m is divisible by n. That's the meaning of that. So when I say n divides m, so n is the divisor for m. M is the dividend. So then we have to talk about which type of relation. See, good that in this question they gave natural number. If they could have said real number, no, it is surely not reflexive because 0 cannot divide itself. Correct, na? So here, coming to, and see this one more thing. Usually we have n comma m belongs to R. Other way of writing this will be n related to m. Similarly, no, let us suppose that A comma B does not belong to R. This we can write as A not related to B. One slash will be given on that. Okay. Now let us proceed. Let us pay attention. Let us go ahead. Question number. Okay, they're talking about the divisibility. Coming to the reflexive. Reflexive, what should happen? Same element. Yeah, if it is the same non-zero element, it will divide itself. Every element will divide itself. So A divides A. So this will be A comma A will always belong to R. This will happen for all the element in the set of natural number. Therefore, yes, it is reflexive. But coming to symmetric, see carefully. We'll take one example to understand. So since see this, 4 is divisible by 2, but 2 is not divisible by 4. There's no such notation. I just wrote because in one marker there's no need to show the steps. So it's not divisible, therefore not symmetric. What about transitive? What about transitive? See, coming to transitive, what should happen? A comma B should be there, then B comma C should be there, then A comma C should search. Now see, if I'm saying A comma B belongs to R and B comma C belongs to R, one common sense logic, see carefully. Here, N comma M related to R. So N, okay, the second letter should be divided by first letter. So here, see, second letter M is divisible by N. How to write mathematically? M divisible by N. M is second letter, N is the first letter. So here also B is divisible by A, and here second letter C here. Correct? No, C is divisible by B. See this carefully. B is divisible by A. How come? B will have some factor of, surely a factor of A, due to which it is divisible by A. When C is divisible by B, it means that there is a factor, C contains a factor of B. Correct? No. So this implies surely that since there is a common factor here and here, it's very clear that C is divisible by A. Nothing but A comma C should be belonging to R. Therefore, yes, it is transitive. So it is symmetric, transitive, but not I repeat, it is reflexive, transitive, but not symmetric. So for question number 19, which option is correct? Option D. Okay. There is one question on congruency of triangle, question number 20. That will be assignment. Fine. So now let us move on to the next question. Any doubts before we proceed? Any doubts? Okay. Fine. Let us proceed with the next question. Ready? Focus now. Pay attention. Ready, all of you? Now, moving on to the problem. Question says, question number 24. A relation R in the set A is equal to 1, 2, 3 is defined as R is equal to order pair 1 comma 1, 1 comma 2, 2 comma 2, 3 comma 3. If this is given, which of the following ordered pair in R shall be removed to make it an equivalence relation in A? So they are asking which element should be removed to make it what? Equivalence relation. If you see, first for equivalence relation, it should be reflexive. So since 1, 2, 3 is there, 1, 1, 2, 2, 3, 3 should be there. So that is satisfied. And this 1 comma 2 is there, due to which it's not symmetric because 2 comma 1 is not there. So they ask which element to be removed. Surely I should not remove 1, 1, 2, 2, 3, 3. If I remove, it won't be reflexive itself. So surely you have to remove what? Remove 1 comma 2. As soon as I remove 1 comma 2, R will become an identity relation, and every identity relation is a reflexive, equivalence relation. Yeah, it's also reflexive, but when I say equivalence relation, everything is covered. So 24th, which element should be removed? 1 comma 2, option W. Option W should be removed. Okay. Now let us move on to next. Now we are going to go ahead with functions. Okay, fine. That is the board for a while. I think some water. Okay. Let us move on to functions. Yes. Let us recall what is a function. Function is a special type of relation where every element has got a unique image. And we denote a function f from A to B as this, f from A to B. And since every element should have an image, always A is a domain, and the second set B is codomain. And the range is given by f of A. Now, let's understand this. So let's say function. No, we'll go with quickly. 1, 2, 3, and let's say A, B, C, D. Whether f1 is a function or not. See this. Is it a function? Every element should have one image. Image of one is B. Whatever is present here, to whatever we map, that we call image. So image of one is B, image of two is A. So this we call image. And whatever the element having the image, this element we call pre-image. So as you can see here, that we said every element should have got one image, unique image. Yeah, 1 and 2 have got image, but 3 don't have any image. So since 3 don't have any image, therefore it's not a function. F1 is not a function as there's no image. Now if I take one more, F2, 1, 2, 3, A, B, C, D. See this. Image of 1 is B, image of 2 is A. Both have got only one image. But image of 3 is D also, B also. So 3 has got how many image? 2 image. Since it has got more than one image, therefore F2 is again not a function. F2 is not a function. Okay. Now having this, let us move on to the next one. Is then when it is said to be function. See this carefully. Third example. So F3, I will say 1, 2, 3, A, B, C. See, 1 is mapping to A, 2 is mapping to B, 3 is also mapping to C. Now you see, image of 1 is C, image of 2 is B, image of 3 is C. Everyone has got only one image. Yeah, 1 and 3 have got same image. We never said anything about function it to have a different image. We just said it should have a one image. If it is different image, then it is a one function. Okay, so this is, yes, it's a function. And even if I've got like this also, it's a function only. A is mapping to C, 2 is mapping to A, 3 is mapping to D. Yeah, it's a function. One element is left out, no problem. Again, it's a function. Let us suppose this is F4 and it is a F4. F4 is a function. Okay. Okay, fine. Now, having understood this, let us move on to the next part. Now, what will be is types of function. Now, coming to types of function. First one is one function. Other name for one function is injective function. What is this injective function? A function f from A to B is said to be injective function if every element have distinct image. If every element has what? Distinct image, nothing but different image. For a while. Any doubt before we proceed? Any doubts? Things are clear? Okay, so no doubts. Manikandan, you are saying there's no doubt? Okay. Okay, fine. Understood. Okay. Now, coming to types of function, coming to one, every element should have a different image. See carefully. And here we are going to analyze some of the things here. All should have unique image, but it should have what different image. So let's suppose here 1, 2, 3, and you have A, B, C, D. So one image is a C, 2 images A, 3 images D. All have got different image. This we call what? One function. So here this is also one function. Okay. Oh, we have mapped the same way itself. Yeah, no problem. Now see, but this is a function, but not a one function because 1 and 3 have what same image. This we call many one function. A function which is not one is known as a many one function. Other name for one function is injective function. And here I would like to talk about number of element in domain and codomain to be one function. The condition. See this carefully. See this carefully. If now see here we have 3 elements. Here we have got 4 elements. Presently, number of element in A is less than number of element in B. Let us suppose I include one more element here, 4. Then I can map to B. So it means it can be equal also. Less also, if I have got number of element less than number of element in domain is less than number of element codomain, then also it is one function. We can have one function. Even if I have got same number of elements also, it can be Again, what? 1 function. Now, if I include one more element 5 here, now you see, if I won't map, it's not a function. But if I map 5, I have to map among A, B, C, D, any one I have to map. As soon as I map to any one of them, it will not have different image. It will have same image. Therefore, it's not a 1 function. So, condition for a function to be 1 should be number of element in the domain should be less or equal to codomain. If it is more than, so here you can see, if number of element in the domain is greater than number of element in the codomain, surely it is which function? Many one function. Okay, equality I'm not writing. For equality, for example, no, if I take 4 here, still if I 4, in place of mapping to B, if I could have mapped to A, C, or D, then also it could have been what? Many one function. But surely if number of element in the domain is more than the codomain, is not a 1 function, then it is what? Many one function. So this is one example of many one function. Now comes onto function. Now what is onto function? Coming to onto function, every element in the codomain should have an image. Pre-image, I mean to say pre-image. So here, if I have got any element here, the pre-image should be present here. Okay, only then you say it is a what? Onto function. In short, each and every element should be mapped. So let us, and here, let us try to understand this. Here I take 2, and here let's say 6, then 7. Now see carefully. I'm mapping to this 6, and then here. Now, x is also mapped to what? Y only. Now, is it a 1 function? No, it's onto surely, because all the element of the codomain are mapped, or every element in the codomain have got pre-image. As I said, no, that the first element present here we call it a pre-image. So every element, I repeat, the element having the image in the first set is known as what? Pre-image. 3 don't have image, therefore it's not a pre-image. Okay, I saw a function first of all there. Now you see, every element have got one image, therefore it's a function, but it's not 1 function. Coming to onto, all the elements have got pre-images. Yes, and here you see very carefully, range and codomain are same. Range and codomain are same. Range is equal to 6y. Codomain is also equal to what? 6y. So range and codomain are equal. Now next point to be understood is about number of elements. See here, how many elements do we have in set A? 3. In how many elements we have got in set B? 2. So number of element in A is greater than number of element in B, and it is onto. Now let us try to increase the number of element in B. If I have, let us suppose, no, one more element, let us suppose 1, then also anyone I can take and map here, it is still onto. Still on nothing, but even if I have got equal number of element also, no problem, it is still what? Onto. Now the question is, if I increase by one more element, let us suppose 8. Now you have insufficient element in the codomain, you cannot map to 8. So in short, as soon number of element in the domain is lesser than the codomain, it will not be onto. In the 1 cases, it was other way around. Okay, that number of element in the domain should be less than or equal to codomain, only then it is onto. Now as soon I included one element, there is no image, then we say it is what? Into function. Okay, into function. Into function, function which is not 1. Other name for onto function is surjective function. What's the name? Surjective function. Okay, fine. And one more thing, bijective function. What is bijective function? A function is said to be bijective. See, I didn't got separately for many one and into. It's understood. So don't think only 3 type we have, 25 type we have. Coming to bijective. When do we say a function is bijective function? A function is said to be bijective function if it is both 1 and onto. Now see carefully, and I said 1 and onto. 1, 2, 3. A, B, C. 1 can map to C. 2, let us suppose, map to A, and 3 map to B. Now it is 1. Every element have got different image, and all the element in the codomain is map. Nothing but all the element have got pre-image. Therefore, it is what onto also. So it is both one and onto. And see carefully about number of element in this. Set A has got A, set B has got set A 1, 2, 3, and set B is ABC. Number of element in the domain and the codomain are same. Only then it will be bijective. As soon as you see number of element in the domain and codomain are not same, directly you can comment that it's not a bijective function. How, sir? Just see. If I include one number element, let us suppose 4 here. Now this 4, if I want to map, it's not a function. If I want to map, I have to map either to A or to B or to C. As soon as I map to any one of A, B, C, it's not a one function. Correct now? Okay. So number of element in the domain can't be greater than number of element in the codomain. So first I will remove this. Let's suppose I will add one element D here. Now again it's one function. It's one function now, but not onto, because codomain element D don't have any pre-image. Correct now? So it will be a into function. That's the reason, if at all the function should be bijective, number of element in the domain and the codomain should be same. So having all this information, let us proceed with the problem. Okay. And one more thing. Okay, let us proceed with the next. One more thing I want to quote here. See, this is not one, nothing but many one. So you can see F3 is taking the element 1 to C. So whenever we just see now F3 of 1 is equal to C, and F3 of 3 is also 3. 3 is coming in next because I have taken 3 here. Okay. So whenever for 1, no. What's the definition? If F of x1 is equal to F of x2, this implies that x1 is equal to x2. X1 is equal to x2 for all x1 comma x2 belonging to the domain. Let us suppose that f of x1 is equal to f of x2, but x1 is not equal to x2. For example, here no, f of 1, f3 of 1 and f3 of 3 both are equal to c, but 1 is not equal to 3. But 1 is not equal to 3. Therefore, it's not a one function. I hope this point is clear. Fine. So with this, let us proceed. Yeah, some students have joined. Gautam Reddy. Okay, my student of the year 2023. Okay. Then one more is Ruhul Khabir Muhammad. Yes, on Islam. Okay, yes, wish you the same. Ramzan month is arriving. Yeah, wish you the same. Okay, fine. Let's move on with the problems. Concept I've given now. Let us move on with the problems. Coming to the question. Before proceeding, any doubts? Okay. Any doubts? Okay. Fine. Now let us proceed with the problems now. Moving to the problems. See, and one more thing. Graphically, how to know a function is 1 or not 1? Very simple. Whatever the graph you have got, for example, this graph, is it a function? First of all, for a function to get identified, we have to draw a vertical line. Let us take another color marker. We have to draw which line? Vertical line. If I draw a vertical line and if there is no point of intersection, more than one point of intersection, only then it's a function. But coming to which one? 1 function, we are going to draw horizontal line. And if you have got more than one point of intersection, then this graph is not 1 1. Okay, it's a function. First you can see, you can draw a vertical line, only one point of intersection. Okay, so let us suppose I've got one curve like this. Now draw, let's draw a bit more better. One curve like this. Now you draw, but before drawing horizontal line, draw vertical line. You have got only one point of intersection, therefore it is 1 1 function. And if you see very carefully, this increasing function. So every strictly increasing function is 1 1 function. Similarly, every decreasing function is also what? 1 1 function. Strictly decreasing, not just decreasing or not increasing. Because for increasing, decreasing, for some set of values in the interval, they can be equal also. As soon as they are equal, the horizontal line will have more than one point of intersection. Therefore, it will not be what? 1 1 function. Okay. Now let us take the problems. Kindly focus. Now, moving on to question number 27. It says, let f be a function from R to R defined by f of x is equal to x power 4, where x is a real number. Then they're talking about types of function. See, let I just give a note. Always remember, whenever power of x is even, whenever power is even, okay, n can be any integer. Okay, n can be any integer, but if I take 0, yes, even for that also will work. Whenever it is even power and n is integer and your domain is R to R. Domain is what? R to R. It is always is not 1 1, definitely. For example, x n is equal to 1. If I take x square for the curve like this, then if you draw horizontal line, more than one point of intersection, therefore it's not a 1 1. Not only for this, no, when if it is a natural number, no, if it is a natural number, your x power 2, x power 4, x power 6, x power 10, all you have the same form only. And again, it's not a 1 1, provided it is R to R. So why you said R to R? Anyway, it is not known. See carefully. If I give you the same question, f of x is equal to x square. F is a function from closed interval 0 to infinity to R. So f of x equal to x square, that is given here, is a parabola starting like this. Correct? No, this is 0 here. But as soon as I said 0 to infinity, be careful. The curve is not going to start in the negative part of the x-axis. It starts from 0 to infinity. This is your code. This is your domain. This is your codomain. Domain comes from the x-axis. Codomain comes from the y-axis. So you can see from here it goes. And you draw a horizontal line. How many point of intersection? Only one point of intersection. Therefore, it is 1 1. Here it was not 1 1. Same graph equation, but restriction of domain and domain gave us what? It to be what? 1 1. That's what I said. Yeah, from R to R, x power is even. It's always what? Not 1 1. See, okay. Again, also not 2. Onto, provided it is what? R to R. If you just see R to R and power is even, always is this neither 1 1 nor onto. Here also, no, it's not here. See, f is 1 1, but not onto. But just see how we can make it onto. If I same problem, no, I'll take this as question number 1. Yeah, here 1, and this is 2. 3, you see, f of x is equal to x square. F is a function from closed interval 0 to infinity to again closed interval 0 to infinity. So now, why it is not onto? Because here the range. What is the range here? What is the range here? Range, how to see? See y-axis up to where the graph is covered. So if you see the y-axis, negative part of y-axis, there's no graph present here. From 0 to positive part of y-axis, that is plus infinity. You can see graph is present here. Therefore, the range of this is closed interval 0 to infinity. But the codomain is R. This is a subset of R. Therefore, it is not onto. Therefore, it's not onto. Now you see this. I given 0 to infinity for both. So the graph, since it is 0 to infinity, it will start from here and moves up. And it's plus infinity, then 0 here. Now here, for this part of y-axis, the graph is present. Therefore, the range of this will be closed interval 0 to infinity, which is also same as what? Codomain. Codomain is 0 to infinity. So whenever you see that codomain and range are same, it is what? Onto function. Here it is onto and 1 1. Hence, onto and 1 1. Nothing but bijective function, and inverse exists. So what I'm trying to say, same function f of x equal to x square, f of x equal to x square again here, but depending on, here we said f is a function from R to R. So what I'm trying to convince you is, it's not only the function deciding the nature or the behavior, or like I said, types of function, it's also domain and codomain given to you. So as soon as it was R to R, it was neither 1 1 nor onto. As soon as I gave domain to be closed interval 0 to infinity, then it became what? 1 1, but not still onto, because codomain is R, range is 0 to infinity. But as soon as I change the range also to 0 to infinity, now it is 1 1 and onto. So you have to be careful with all. Okay, doesn't I give the condition as R to R, only then it is what? The bijective function. Okay, so having this, let us try to move on to the next. Let us erase this. I hope it's clear now. Any doubts? Any doubts? Is it clear? No doubt. Okay, money. How's your preparation going on, Money Kandan? Okay, good. Good, sir. Fine. Now let us move on to the next question. Question number 27. Okay, that's all you're discussing, no? As again, right, and have not concluded with the option x power 4, and f is a function from variable R to R. So R to R, it is neither 1 1 nor onto. As we know, the graph of this is parabola shape, but not parabola, looking like parabola. So it is not 1 1 and onto. Therefore, the answer is option D. Now you see 28. See, the way I commented for even power. Now, similarly, if you have got f of x is equal to, as a note, you can make a note that if at all f of x is equal to odd power where n is any integer and f is a function from R to R, then f is always bijective. Then f is bijective. Nothing but both 1 1 and onto, provided power is odd. And you can see, 2n is even, but 2n minus 1 or 2n plus 1 is what? Always odd. Now having this, let's move on to the next problem. Question number 28 says f is a function from R to R defined by f of x is equal to 3x, where x is a real number. Then they are asking the option. Then option A, f is 1 1 and not onto. Option B, f is 1 1 and onto. Option C, f is many 1 and onto. Option D, f is neither 1 1 nor onto. So as we just discussed, for power odd, power of x is what? 1. 1 is odd number and is R to R, therefore it's bijective, which is there in question number 28, option W. Okay, now see question number 29. F is a function from R to R defined by f of x is equal to x cubed. Again, they have said x is a real number. See, they're not given codomain. Codomain, when it's not given, it's understood that it is what? R itself. We are dealing with real valued function where the domain and codomain are set of real numbers or the subset of real numbers. Correct now? So now Since again power is odd here, it is bijective. So for question number 29, 1 and on to option W is correct. Okay, after knowing this logic, in no time you can get the answer. Question number 30. And if you want to see the graph, this will be what? A line passing through the origin, y equal to 3x. The line will be like this. And so 1 on 2 function. The graph as this, we know. One point of inflection also was discussed in AOD. Yeah. So this is y equal to x cube. Now moving on to question number 30. F is a function from R to R. Then defined by f of x is equal to 1 by x, where x is a real number. I would like to see who will answer. Then f is option A 1 1, option B on 2, option C bijective, option D f is not defined. Let's see how many will comment on this. Till then, drink water. Till then, come with water. Answer that. Yes. Let us see how many of them have answered. I drink some more water. Okay. Yes, Alia has said question number 30, option D. Yes, all of you see carefully. That's what no. X is belonging to all they have said, but this is 1 by x. Denominator, the x should not be equal to 0. From the domain, they should not have what? 0. So the domain, the first set A is not domain. The first set R is not a domain. Domain is from R, remove 0. If x is equal to 0, 1 by 0 is what? Undefined. 1 by 0 is undefined. Therefore, option D is correct. Yes, Salia, you're right. Okay, let's move on to next. Now moving on to next. Moving on to next problem. Question number 31 says, yeah, if a function is bijective, it is invertible. So question number 31, if f is a function from R to R given by or defined by f of x is equal to 2x plus 6 is bijective function, then we have to find the inverse. So how to find inverse? Solve for x. So I'll equate the given function to y, and you can see R to R power is always what? It is a linear equation. So whenever power is odd, it's a linear equation, linear or straight line it is. Y equal to mx plus c type by intercept form. So it will be obviously what? Bijective, because it is 1 1 and on 2. Solve for x, transpose this here. Y minus 6 is equal to 2x, divide by 2. So I'll get cross multiply. So y minus 6 divided by 2 is equal to x. So now if you see the option, I write the options for you. If I see the options here, option A is x by 2 minus 3. Option B is 2x plus 6. Option C is x minus 3. Option D is 6x plus 2. Okay. Now here if you see all items of what x. So fine, this is actually our f inverse of y. What's happening here? What's happening here? F is a function from A to B, and f inverse is taking it back. Right now we are coming back from codomain to domain. So here it is x to y, and here it is y to x. So now here what will be f? See, f inverse of y. What's the meaning of f of x? I am writing y in terms of x or a constant. That's what no. And here f inverse of y means my expression is in terms of y or a constant. So yeah, y. So but I want f inverse of x. No problem. In place of y, x. Put here x minus 6 by 2. Is it matching? There's no fraction here for three option. Only for this option have fraction. Come on, simplify. 2 divides x and 6. So x by 2 minus 6 by 2. 2 ones are 2 threes are. So answer is x by 2 minus 3. Yes, option A is correct. I hope it is clear. Any doubts? Now let us proceed to the next. Now from here comes number of one function, non-two function. Let I give the formula for this. Actually, in PUC, not even a single question we have got as such, but we are having a question, an exam also, and even a question bank also it is been asked. So see carefully here. Let us suppose if f is a function from A to B, then first point, number of function from A to B is understood is number of element in the codomain, that is B, to the power number of element in the domain. This will be the formula for number of function. Second point, what about number of one function? Number of one function will be number of element in the codomain permutation number of element in the domain. Don't forget in one we discussed already that codomain should have more element compared to domain. It's a permutation concept. And next is number of onto function if number of element in the codomain is 2. I have got only 2 element is 2 to the power of number of element in the domain minus 2. Okay, now see from here itself we can also ask number of many one function. So we have subtract this 2, we'll get many one function, because if I remove from function one function, I get what many one function. Similarly, number of into function, from this number of function remove this, you'll get what number of into function. Now comes the last one, number of bijective function. Number of bijective function. So as you know, for bijective function, number of element in domain and codomain both should be what same. And the formula to find number of bijective function will be number of element in the domain A factorial or number of element in the codomain B factorial. You can take anyone because ultimately both are what same. And how to go for factorial? For example, if you have 5 factorial, what's the answer? 5 into 4 into 3 into 2 into 1, which will be 120. And I fill the ink. Just give me a minute. Yeah. Till then, any doubts? For a while, I am filling the ink. Any doubts? For a while. Yes. Now we are ready. Let us proceed now. Okay. Fine. So having the information about all these types of number of functions, now we will go ahead. This is nowhere in your NCERT text. So it's additional information given by me. With this, surely you can find many of those solutions now, which we are going to take one by one. So let's proceed now. Let us not erase this. Okay. Now we are talking about the question number 32 now. Yeah, color is far better now. The boldness, brightness. Question number 32 says if the set A contains 5 elements, so number of element in the set A is how many? 5 elements. And the set B contains 6 elements. Number of element in the set B is 6 elements. Then the number of 1, 1 and onto mapping, nothing but bijective they are asking. For number of 1, 1 and onto mapping, nothing but bijective function. First condition is number of element in A and B should be what? Same. Are they same? No. Then don't think question is wrong. Then answer is 0. It can't happen. As soon as I include one more element here, there is no bijective function itself. No means what? 0. Count is 0. So the answer for this will be option C. Next comes question number 33. Let A is equal to 1, 2, 3 moves on up to n, and B is equal to A comma B. Then the number of surjective function from A into B. Surjective, nothing but onto. For coming to onto, if number of element in the codomain is 2, then this is the formula. Yeah, codomain you can see number of element in the codomain is 2. So the answer is 2 to the power of number of element in A minus 2. How many elements do we have in A? N number of elements. So answer is 2 power n minus 2. 2 power n minus 2. There in option blue. Okay, I hope this is clear. Now let us move on to the next question. Question number 34. It says if the set A, I would like you to answer this. If a set A has 5 elements, so number of element in A, set A is 5 elements. Number of element in the set B is 6 elements. Then number of 1, 1 function. We have to talk about number of 1, 1 function. Formula is given here. I'm waiting for you to answer. Number of 1, 1 function. Yes. Get me the answer for number of 1, 1 function. $34 answer is okay. 34 answers option A. Yes, Alia, you are right. She's having that. And anyway, for all the students, even in our description also, we have given the link for question bank issued by PU board and all the 3 model question papers as well. Yeah, so as we know that it is this formula. So it is number of element in B permutation, number of element in A. So number of element in B permutation, number of element in A. So this will be 6p5. So after the formula, what is NPR? Either you can use NPR or direct common sense. Is C here. Or number 6 or number 5. Start writing less than or equal to 6, the natural number, but only 5 numbers. Less or equal to 5 numbers. Sorry, less or equal to 6 numbers, but only 5. Okay. So 6, then 5, then 4, then 3, then 2. Count how many are there? 1, 2, 3, 4, 5. When you multiply, you'll get 120 into 7 will be 720. 120 is 5432. So this I have multiplied. No, I remember it's 120 into 6 is 720. Okay. So option A. Now, having done that, now we will take one question number 37, where you should talk about bijection, nothing but bijective function. Question number 37. We want bijection. Which of the following is bijection? And the function is from z to z. So the first option, A, is f of x is equal to x cube. Okay. F of x is equal to x cube. Second option, f of x is x plus 2. Third option, f of x is 2x plus 1. And the fourth option, f of x is x square plus 1. So they're asking which of the following among is bijection, nothing but bijective function. Let us see who will answer. Okay, Manikandan also answers 720. Okay, good. Yes, anyone with the answer? Okay, right, solve it. See, for this you can take first most important is not R to R, okay? So you have to be careful. If I take arrow diagram, which I call in our usual case banana, it is Z to Z. So it is 0 here, 0. Okay, 0 cube is 0. If I've got 1 cube is 1 only. But if I've got 2 cube is 8. So you can see 2, 3, 4, 5, so many are left out. And between 1 and 2, we don't have any integer to fill them. Therefore, it's very clear that it's not 1, 1. Sorry, it's not on 2. It's 1, 1 surely. See, whenever power is odd, no, it's always 1, 1. So F is 1, 1, but not on 2. Come to this one. If you see f of, again, z to z it is. So again here, if you just see 0, 1, 2, minus 1, minus 2. Again 0, 1, 2, minus 1, minus 2. Put x is equal to 0. 0 plus 2 is 2. Put x is equal to 1. 1 plus 2 will be 3. Then put 2. 2 plus 2, 4. Understand here. Don't think, no, the element which is there here is not mapped. It is mapped. Minus 1. Put x is equal to minus 1. Minus 1 plus 2 is plus 1. Minus 1 plus 2 is a plus 1. Then minus 2. Minus 2 plus 2 is a 0. So above also it will map, below also it will map, and it will map, and it will never stop. It's infinite set. So it is what? Bijective. 1, 1 also, on 2 also. 1, 1 and on 2. So bijective. Therefore option W is correct. Even though we got the answer, let us understand the problem still more in detail. Here you see 2x plus 1 thing, but odd is going to only map to odd numbers. See carefully yourself. 0, 1, 2, minus 1, minus 2. 0, 1, 2, 3, 0. 2 into 0 is 0, 0 plus 1 is 1. Then x1 is 1. 2 ones are 2. 2 plus 1, 3. Then x equal to minus 1. 2 into minus 1 is minus 2. Minus 2 plus 1 is minus 2 plus 1 is minus 1. Then x is equal to minus 2. 2 into minus 2 is minus 4. Minus 4 plus 1 is minus 3. So minus 2 is left out. So it is again 1, 1 and on 2. Again here the power is odd. Whenever power is odd, it's always 1, 1. No doubt about it, because it will not convert negative to positive. Positive will remain positive, negative will remain negative. Now here you see I square plus 1. So as soon as I got even power, take positive and negative number. F of minus 1 in place of x minus 1. So I'll get minus 1 the whole square plus 1. So I'll get 1 plus 1 nothing but 2. F of plus 1. So put here 1 square plus 1. 1 square is 1 plus 1 nothing but 2. F of minus 1 is 2. F of 1 is also 2. So here very clearly f of minus 1 is equal to f of 1 is equal to 2. But see, images are equal, but pre-image is not equal. So minus 1 is not equal to plus 1. Or if you want, take a banana. What's happening? Both minus 1 and 1 are mapping to which number? 2. Correct, no? So therefore it's not a 1, 1 function. And so it's not on 2 also, because it's only going to cover positive numbers. Okay? Positive numbers, but not all the 2. Not 1, 1, not neither 1, 1 not on 2. Neither 1, 1, neither 1, 1 nor on 2. So which option? Anyway, I already got B. I just completed the problem. Now let us proceed with the next. Any doubts? Kindly comment. Do you have any doubts? Do you have any doubts? Okay, no doubt. Fine. Okay, let us proceed. So now, moving on to the next question. Question number 39. Before we go ahead, recall, when do we say a function is invertible? A function f is said to be invertible. A function f is said to be invertible from f from a to b if there exists a function g from b to a if fog is equal to identity function and gof also is equal to identity function, and we denote g as f of minus 1, which is not equal to 1 by f. And a function is to be invertible. The function should be what? Both 1, 1 and on 2. So having this logic, let's try to go ahead with the problem. Question number 39 says, let SB is equal to A, B, C, and TB is equal to 1, 2, 3. Then which of the following functions from S to T? So which of the following function, let's say function is f from a to s to t. For which of this f inverse exists? Oh, f inverse exists. So I have to give the option this time. So don't forget for a function. Let's see who will answer. So option A, f is equal to a comma 3, b comma 2, c comma 1. B, f is equal to a comma 1, b comma 1, c comma 1. Then for option C, f is equal to a comma 2, b comma 1, c comma 1. Then for option D, f is equal to a comma 1, b comma 2, c comma 1. Yes, let us see who is going to answer. Which option is correct? Let me know the answer by you people. I'll just drink water some more. Yes, any doubts? What's the answer? Okay. Yes, what's the answer? Okay, let's solve it. Pay attention. See, yeah, if at all it is what inverse exists, it should be 1 1 and on 2. So don't forget, just see one by one. The first element in the ordered pair will be pre-image and second element will be image. Since you can see second element all are different, nothing but images are non-repeated. Okay. And A, B, C, all pre-images are different. Nothing but every element have got only one image, and those images are different. Therefore, this is 1 1. And since range you see 3 2 1, yeah, codomain, no. Whenever range and codomain, let us recall. If at all you have got x comma y, in terms of order to, if we talk about, listen, always our first element of the order pair will be domain if it's a function, whereas the second will be range. So here, if you see, let's try to draw the graph itself for this to be clarified. So set S is ABC and set T is 1 2 3. A is mapped to 3, B is mapped to 2, and C is mapped to 1. You can see very clearly it's 1 1 function and on 2 function. Therefore, option A will be correct to have inverse. Whereas option B, you see the second element repeated. Nothing but A, B, C have got the same image. Since the image is always 1, it's not 1 1. And it's not on 2 also because range is always 1. If you want, you can see the diagram here. B, see this carefully. A, B, C. And again here 1 2 3. A is mapping to 1, B is mapping to 1, and C is also mapping to 1. So here range is 1, codomain is 1 2 3. Therefore, it is not 1 1, not on 2. Coming to option C, again, if you go for A, B, C, and then here 1 2 3, A is mapping to P. See, before seeing there also, B and C is having same image. Therefore, it's not a what 1 1 function. They should have what different image. Correct? No. If you are strong enough, no, there's no need of going for odd diagram also. A is mapping to 2, B is mapping to 1, C is also mapping to 1. Only A is mapping to 2, and 3 don't have any pre-image, therefore it's not a onto, it's also not 1 1, not onto, neither onto nor 1 1, neither 1 1 nor onto. For this also same. Coming to the ABC. A is mapping to 1, C is also mapping to 1. Again, they have got same image. Therefore, it's not again. This have to you can plot yourself the diagram. So for question number 39, we got a very good clarity about just by seeing how to comment. Okay. I hope this is clear. Now moving on to next problem. It is the wood. Now moving on to next question. Question number 40. Number of all 1 function. Okay, here see carefully. 40 I'm being purposefully here. Number of all 1 function from the set A is equal to 1, 2, 3, 4. To itself. Let's see, you will answer. Number of 1 function to itself. Come on. Number of 1 function to itself. Yes. How many number of 1 function we can have? Manikandan says 6. Centerfall says 24. Okay. See, I gave you a formula. Number of 1 function is number of element in the codomain permutation, number of element in domain. But in the question they said it's from set A to itself. Nothing but set A and set B both are same. So substitute here 4, and number of element in this is 4. P4. Recall what is NPN? It is n factorial. So 4P4 will be 4 factorial. What's the answer? 4 into 3 into 2 into 1, which is 24. Okay. Fine. Alia says B. Yeah, option Baglu. Now, very interesting question that have been answered in the concept. I hope one thing is very clear for the people to understand. Concept is so important. If concept is done now, you just see this question, how good framed it is. Question number 42 says, let f be a function from 1, 2, 3 to again 1, 2, 3 is a function. Statement 1. What is statement 1? It says if f is 1, 1, then f must be on 2. Then f must be what? On 2. Similarly, coming to statement number 2, one more statement is given. If f is on 2, then f must be 1, 1. So then choose the correct answer. Option A. Option A is statement 1 is true and statement 2 is false. Option B, statement 1 is false and statement 2 is true. Option C, statement 1 is true and statement 2 is true. Option D, statement 1 is false and statement 2 is also false. Come on. Let us see. What are you going to say? No one. Okay. That I completed. See, they are saying in the domain and codomain, no, they are given three elements, and in the, it's A to A. I mean to say 1 to 3 to 1 to 3. So here 1, then 2, then 3. Again 1, 2, 3. For F to be 1, 1. If F is 1, 1, then F must be on to. Come on. Coming to statement number 1. Make it 1, 1. If I make it 1, 1, whatever you make, way you do, this is 1, 1. It's also on to also. Correct? Then statement number 2. If F is on to, is it on to? Yes, on to. It's also 1, 1. See why it's happening? Because number of elements are what? Same. Whenever number of element domain and codomain is same, it's always what? The bijective function. We have already mentioned here. If at all, you should have both 1, 1 and on to. Now, if number of elements are same, as soon as 1, 1, it will be on to. As soon as on to, it will be what? 1, 1 itself. That's what concept are so important. I hope it's clear. Okay, now let us proceed. How does come back cursor, please? Where have I went? Okay, let's proceed to the next. Any doubts? Okay. Now let us move on to next. So now moving to the next problem. Question number 44. Listen carefully, a very good concept based question. And here we have statement number 1 saying, consider the set A is equal to 1, 2, 3 and R be the smallest equivalence relation on A, then R is an identity relation. First comment about this. If R be the smallest equivalence relation, can we say that it is an which one? Identity relation. See, for a relation to be smallest equivalence, we should have order pair equal to number of element, and that order pair are 1 comma 1, 2 comma 2, 3 comma 3, and this is what equivalence relation, and it is all equivalence relation first ER, and it is also what equivalence relation it is, and also it is identity relation. Yeah, statement number 1 is correct. Moving on to statement number 2, what it says. 44. Statement 2 says R is an equivalence relation, then R is reflexive, symmetric, and transitive. Yes, by definition. So statement number 1, true. Statement number 2 is also true by definition of equivalence relation. Now the options are option A, statement 1 is true and statement 2 is false. So option A out. Option B, statement 1 is true and statement 2 is true. Statement 2 is a correct explanation for statement 1. Yes. In statement 2, they said about definition about equivalence relation, that nothing but should be reflexive, symmetric, and transitive. By using the result, I have commented that this is equivalence relation. Therefore, option B is correct. Let us move on to question number 45. Again, assertion reason type question. Question number 45 says, in the set A, given to us 1, 2, 3, be a relation R as R is equal to 1 comma 1, 2 comma 2 is reflexive. This is the assertion. Assertion A. Then the reason is for it to be reflexive, we should have A comma A belongs to R This should happen for all the element of the set A present in set A. Element A, small a present in set A. So statement 2 is definitely true because of definition of reflexive. Coming to statement number 1 or assertion, what do you say? What do you say for statement 1? Statement A. Sorry, assertion. Assertion. Is it reflexive or no? Is it reflexive or no? Is it reflexive? Not reflexive, yes. Ali also says A is false. Manika also says not reflexive, yes. As you can see here, 3, 3 does not belong to R, therefore not reflexive. Since it's not okay, so this is false. They said it is reflexive, right? They said it is what? 45. They said it is reflexive. So assertion is false, whereas reason is true. So which option? Assertion is false, reason is true. Option A is correct. Now, question number 46 will be assignment. Coming to question number 49, a very good question. Doesn't mean that the meaning are not good, okay? But interesting question it is. Now you see, question number 49 says, statement number 1, the function f from R to R defined by f of x is equal to 0 when x is rational number. They wrote in word, I wrote in symbol. Anyway, we are math teacher, we are math student, so let us have in mathematics language. And here 1, when x is an irrational number, nothing but does not belong to rational number, is bijective. They are saying this is bijective. Statement number 1. Statement 2 is a function a function is said to be bijective if it is both 1 1 and on 2. So statement 2 is true. Definition. Right now. Now you see. Let us take a banana. So it is a real number. So real number I can categorize into 3. One is 0. I will give separately. Anyway, I can categorize it only into 2. What? One is rational number, other is not a rational number. Here also not a rational number, and again rational. How to know? The entire talk is about rational and irrational. Now they are saying whenever element is 0, it should map to rational number. I mean to say whenever element is rational, I mean to say whenever element is rational, it should only map to 0. 0 will be somewhere here, let us suppose in rational. So this entire thing, this entire element, whatever is there here, all are going to whom? 0 only. For example, 1 is a map to 0 only. Minus 2 is a rational number, again map to 0. Very clearly, it's not 1 1. F is not 1 1. Coming to on to, let us complete this also. When it is not rational, it should map to 1. So this entire thing, let us suppose 1 is here. This entire thing should map to 1 only. So it means to say that if I got square root of 2, it should map to 1. If I've got root of 3, that should also map to 1 only. Again, not 1 1. And one thing is very clear, it's only mapping to 2 numbers, 0 and 1. It is leaving so many elements. Okay, therefore it is not onto also. So coming to onto, what is the range here? The range of this is 0, 1, which is subset of the real number R. Therefore, it is not onto as well. So which option? Coming to question number 49. First statement is false, second statement is true. So option blue. Now moving on to the next problem. Question number 54. The number of equivalence relation containing 2 comma 1 on the set A is. How many relation can we have containing this? Question number 54 is a fill in the blanks. I would like to see how many can answer this. After that, one more question that will wind up this chapter. Question number 54. Manikandan, have you answered for question number 54? Question number 54. Alia's survey says only 2 relation possible. Okay. Fine, let's try to solve. Set A contains 1, 2, 3. And they are saying number of equivalence relation containing 2 comma 1. 2 comma 1 number of equivalence relation. So how many relation possible? First relation is, see, first it should be reflexive. So 1, 1, 2, 2, 3, 3 is obvious. Now here they are saying I should have that relation containing what? 2 comma 1. So let us have 2 comma 1. If we have 2 comma 1, for it to be reflexive, this 3 element is enough. For symmetric, since if A comma B is there, should be B comma A. So 2 comma 1 is there. So 1 comma 2 should also be there. As soon as I write this, it is what? Symmetric. Is it transitive? 2 comma 1, 1 comma 2 should give us 2 comma 2. Yeah, it is there. 1 comma 2, 2 comma 1 should also give us 2 comma means 1 comma 2, 2 comma 1 should give us 1 comma 1. That's also there. Before you go ahead, no. First, try to always have a count of how many elements do we have in universal relation. Because as soon as you come to universal relation, there is no need to check further because universal relation is A cross A. That's the biggest. So, number of element in universal relation A cross A will be number of element in A into number of element in A. How many are there? 3. So, 3 into 3 will be 9. So, max to max, we can have 9 elements. So, anyway, with this, it will be equivalence. One more relation. First 3 element is mandatory for reflexive, but since they said 2 comma 1, as soon as I said 2 comma 1, 1 comma 2 should come. Now think which next. If I write 2 comma 3, if we have 1 comma 3 first, fine, first 2 comma 3. For 2 comma 3, what should be there? 3 comma 2. Correct? Now, as soon we have got this, see carefully. Is it symmetric? Yes. But is it transitive? See carefully. 1 comma 2 and 2 comma 3. If 1 comma 2 is present and 2 comma 3 is also present, this 2 is there. What is expected? 1 comma 3. Do we have 1 comma 3 belongs to R? No. So I should include that also. 1 comma 3. The delta is what? 3 comma 1. Now you count how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we want. But I just want you to have one scenario. See carefully. See carefully. What if I take only this? Is it equivalence? Check it out. What I am saying, no. As soon as we went no, we took this. But in place of taking this, if I take this, then what you can see? Is it not? It is equivalence relation? I want to think. Can anyone give me the comment? Is it equivalence relation or no? Yes, Alia, 54 2, and many can also say option B. Can you think with respect to this what I've said? Not equivalence. Can anyone say the reason why it is not equivalence? Two comma three is absent for, yeah, transitive. Very good, money content. See here, 2 comma 1 and 1 comma 3. If I take 2 comma 1 belongs to R and 1 comma 3 belongs to R, this is same. What we expect 2 comma 3? 2 comma 3 is nowhere present in R. Therefore, it is not transitive. So again, I have to include 2 comma 3 here. Then I should write the 3 comma 2 for symmetric. As soon as I write the same as what R2 only, same as what the relation R2 only, same as this. So it is only 2. Whatever you have said is correct. Option B, no. Means number of relations. Fill in the blanks. No, fill in the blanks. So it is 2. Now the last problem from this chapter. Let us see how many can answer this. See carefully and listen carefully. Question number 63 says, statement 1. We have 3 statements to, totally. Coming to question number 63, statement number 1. Listen carefully. If R and S are two equivalence relation on a set A, R intersection is also an equivalence relation. So intersection of two equivalence relation is again equivalence relation, provided R and S are what? Equivalence relation. Second statement, they are saying the union of two equivalence relation on a set A is not necessarily an equivalence relation on the set A. What's the meaning? If I've got R, yes, and both of these are equivalence relation, then it need not be their thing. So we have to check. It may or may not be. That's what they are saying. The way we are, the confirm we are saying here, may not be able to say here. Next, statement number 3. The inverse of an equivalence relation is again equivalence. So inverse of R power minus 1 called inverse of equivalence relation is again equivalence. So nothing but inverse. No. So so if this is equivalence relation, can we say R inverse is also what? Equivalence relation. So statement are given. So option A, all statements are true. Option B, 1 and 2 statements are true, but statement 3 is false. Option C says all 3 statements are false, and option D says 1 and 3 statements are true, but 2 false. Let us see. Then going with that option, no, just you say which statements are true and which statement is false. Let us see who will answer. No one. Okay. Let I comment. See here. It's in fact a very good problem. In NCRT, we have a problem also on this in a general way. Let us take in a particular way. Let I again rewrite this sequence relation. See carefully and pay attention. Let us suppose that we are being given I'll take one example. A is equal to 1, 2, 3. And then I'll take R1 to be one equals relation 1, comma 1, 2, comma 2, 3, comma 3, 1, comma 2, 2, comma 1. Again, I'll take one more relation R2. Again, it will be equivalence relation. I'm trying to comment this problem with the help of example. And such a way that R and S should be what? Equivalence relation. So R is here, S is again this here. So 1, comma 1, then 2, comma 2, 3, comma 3, 2, comma 3, 3, comma 2. Again, it's an equivalence relation. Now, if I go with the first statement, number 1, coming to statement number 1, if I take the intersection of both, what am I going to get? Common element. What's the common in both the relation? Only these 3 elements are common. And what is this? It is identity relation. Every identity relation is what? Equivalence relation. Okay. Next comes statement number 2. Union, if I take. So this was, first of all, coming to statement number 1, this is true. Statement number 1 is true. Coming to statement number 2. Fine. Union, if I take, come on, take the union of R, yes. If I take the union of this, what we are going to have? 1, comma 1, 2, comma 2, 3, comma 3. Then here, 1, union means what? Writing common and common ones together. So 1, comma 2, 2, comma 1. Then here 2, comma 3, and 3, comma 2. See carefully here. Till here it is reflexive, and this is saying it is symmetric also. But 1, comma 2 is there, 2, comma 3 is there. 1, comma 2 belongs to R, and 2, comma 3 also belongs to R. But see 1, comma 2, 2, comma 3, 1, comma 3. What is there? Do we have 1, comma 3? No. Therefore, false. This was therefore true. Okay, this is false. And you should also understand one thing, no? As soon two relations are equivalence, even the intersection is equivalence, it also means that reflexive. If two relations are reflexive, intersection is also reflexive. Intersection and repeat, I repeat, if two relations are reflexive, intersection will be again reflexive. That's the meaning from here. Statement number 1. If two relations are symmetric, intersection is again what? Symmetric. If two relations are transitive, again the intersection is again transitive. That's the meaning from here. Whereas coming to union, you can see it was under union, since R and S are equivalence relation, under union, reflexive is again union of two reflexive relation is again reflexive. Union of two symmetric relation is again symmetric. But coming to transitive, we have a problem. So union of two transitive relation need not be again transitive, due to which it is not equivalence relation. Remember this point, that due to which type of relation the given relation is not equivalence. It's only due to transitive. There is no problem with symmetric and reflexive. Who knows, for 1 mark it may be there. Next, you see, if R is an equivalence relation, inverse of a equivalence relation is again an equivalence dressing. So see, here R is there. If I take the inverse of this, how to find the inverse? Very simple. If you have got the element x comma y belongs to R, inverse will be y comma x belongs to R inverse. I think, but you have just extend the element. So extend the element of 1 1 will be again 1 1. 2 2, extend will be again 2 2. This will be again 3 3. Again this will be 1 2 will become 2 1, and this will 2 1 will become 1 2, and this is again what? Equivalence relation only. So this is also true. Statement number 3 is true. So only statement number 2 need not be. Hello, don't think no. Suddenly, as soon we have got this, so union of two equivalence relation is always not transitive. No, it's not correct. Reason, no. If I take one more relation, let us suppose I'll take one relation here, Q, which is A cross here. What? A cross A, universal relation. Now, when you take union of R and Q, you'll get what? A cross A. And A cross A is what? Universal relation, and due to which it is equivalence relation. That's why they said not necessarily. It may or may not. Okay. So this answer is option. Which option is correct? Union of this. Okay. So here, okay, all the three statements, whatever they gave is true. So they said for this, what they said here for this, the union of two equivalence relation on a set is not necessarily an equivalence relation on the set. Yes, that's also true. So all the three statement is true. So option A is correct. Fine. So with this, we come to an now. Yeah. With this, we come to an end on relations and functions. Now, what do you say? Can we go for inverse trigonometric functions, or we'll take in next class? This week we'll conduct one more Saturday along with matrices and determinant. What do you say, or shall I continue? Because already 3 hours 35 minutes, 3.5 hours. Okay, fine. We will take in next class. Okay, that's what money condenses. Okay, fine. Stop the class. Fine. So, having this journey of online, the third online session for the second PUC, and totally 4 online sessions so far, including first PUC. So, and thank you for your overwhelming response. So, do study well, give 100%. Exam is just near the corner. Next week, 28, your exam will be there. Kannada exam will be there. So, all the very best. Study well, be consistent, be dedicated. Okay, be hunger for just studying. Okay, God bless you all. Thank you very much. And do share, like, subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you all.